Welcome to the session on engineering graphics. In today's session, we are going to see the development of hexagonal pyramid using software. So this is a problem statement which will be given to you. A hexagonal pyramid of base side 30 mm and axis length 60 mm is resting on HP with its base such that two of the base edges are parallel to VP. It is cut by a cutting plane perpendicular to VP and inclined at 40 degrees to HP, and also cutting the axis at a distance of 25 mm from apex. Draw the development of remaining portion of the pyramid. So to solve this problem, we have to start with a line command. So line, a continuous line, and we have to start with the width 0.05. So first I'll draw the XY line. So this is the XY line I have drawn. I name this as X and this would be Y. Then we will be also naming this as VP, and below XY we will be having HP. So they are saying that it is hexagonal pyramid and such it is resting on HP with its base such that two of the base edges are parallel to VP. So I will be starting with the parallel base edge. So this is one of the base edge parallel, then other edge, then other edge. This is the second edge parallel, the other edge, and the other edge. So like this I have drawn the hexagon. Say side we require as 30 mm. So I'll take this equal. I want this equal to this, this equal to this, this equal to this, this equal to this, and this equal to this. So all the sides are equal now. Included angle for hexagon is 120 degrees. So I'll put it 120 degree here. I'll put it 120 degree here, like this. So I got the hexagon. It should not touch the XY line. So I'll take it a little bit down. So this is the hexagon what we have got. So once you have got the hexagon, you can connect the points from this end to this end, this end to this end, and this end to this end. So you will be getting the center as well as you will be getting the slant edges of hexagonal pyramid when you see it from the top. So now you will be selecting the entire thing and you can make it as thick. That is 0.4 like this, and then you can name all the points. So we will be starting with extreme left as A, this would be B, this would be C, this would be D, this would be E, this would be F, and at the center we will be having O and O1. If you want you can exclude O1, but let us include it. So O1 will be having the point. So once we have all these points, we will be taking the projector from O1. Okay, so like this, O1 projector we have taken. Now from this point, this end, we will be taking the axis length. From this end, axis length is 60 mm given, 60 mm. Take this as axis length. Okay, so this is the axis length you have taken. Now you project all the points. You project A, you project B, F, both you have projected, C, E, you have projected, and then D as well. So once you project all these points, you connect them. So from A to this O, then this T, then from E to this O and back to F. So you have got all the points. You also connect this end to this end. So again you can make them thick. So all these edges excluding axis you can make it as 0.4. It is up to you. You can do at the beginning or you can change it after showing the cutting plane as well. Doesn't matter. Then again if you give the namings, you will be having A dash here. You will be having B dash in bracket F dash. Then you will be having O1 dash here. O1 dash. Then here you will be having C dash in bracket E dash, and then you will be having D dash here, and at the end here you will be having O dash. So this is the front view what you have got, and if you name the axis, this would be the axis which is 60 degrees. So now we have to place the cutting plane which is cutting the axis at 25 mm. So from the apex From this point we are taking a 25 mm distance downside, that is minus 90. So this is the distance you have got. So this line you have drawn and you can show this distance. So once you show this distance, you can draw one horizontal line from here, or you can also skip this line. Just you can draw one line from here, from this point draw one line, and we can show the angle with respect to this line with horizontal, that is 40 degrees. They have given it as 40 degrees here. 40 degrees they have given. So we can select this angle here and we can enter it as 40 degrees. So this is the angle what you have drawn. So this is the angle what you have drawn. Now you have to extend this line further. So to extend this, you have to go to extend to next command and extend. Click on this line. If you click on this line, it will get extend. So go to extend to next. So it was selected already. Extend to this line, this line, this line. So this line is extended now. So now you can make this line as chain type, and you can draw a small line at this end and you can draw a line at this end. Now you can select the small line drawn at the ends, okay, and you can make it as 1 mm thick, so the ends should be thickened. Then you can go to the leader, you can click the midpoint of that small line, you will be getting the leader here. Similarly, you will be getting the leader here. Then again you can give the name to this cutting plane as capital S, and here also capital S, like this. So this is the cutting plane which you have placed. Now once you have placed this cutting plane is going to cut the slant edges. So these points you have to mark it. So to mark these points, we will be starting with the text, and A to B and A to O we have to do. A to O is here and it is cut at this point, so we will be naming this as 1 dash because we are naming it in the front view. So A to B is here, it is not cut. Then B to O is here and it is cut at this point, so we will be naming this as 2 dash. Then B to C there, it is not cut, but C to O is here, it is cut at this point, so we will be naming this as 3 dash. Then C to D is not cut, D to O it is here, so D to O is cut here, so that would be 4 dash. Then D to E is not cut, so D to is here, it is not cut, but E to O it is here, which is overlapped by C to O, so we will be having a cutting point on E to O, that is 5 dash. You can keep this point as 3 dash only and you can project it 2 times, but let us not do that. So we will be having separate point on EO also, that is 5 dash. Then E to F is here, which is not cut, but F to O is here, which is overlapped by BO. So F to O is again cut at this point, so this would be 6 dash, and last is F to A. F to A is here, which is not cut. So we have got the 6 cutting points on 6 slant edges. AO is having 1 point, BO is having 2, CO3, DO4, EO5 and FO6. So like this you have got all the cutting points. So once you mark these cutting points, so as we are going for the development of the lateral surfaces, you don't have to project them in the top view. Okay, so let it be like that. So now to project or to have the development of the remaining portion of the pyramid, we have to draw the true length of the slant edges. So here if we see only this AO and DO are parallel to VP, so AO and DO will be representing their true length. So if we check here, so this is AO having a true length, this is DO having a true length. So if we check this edge, it is not having true length. Okay, so these are representing their apparent length because this DO, CO, EO, FO are inclined to vertical plane. So only DO and AO are representing the true length. So 1 and 4 are having on their true length. So remaining 2, 6, 3, 5 are not there on true length. So we have to project them on their true length. So for that you can consider either DO or you can consider AO. So let us consider DO is the edge which is representing true length, and we will be projecting all these points on DO. So first we have to split these lines at the intersection of the points where the cutting plane have cut them. So first we will go to the split. So this line at this intersection, so this line at this intersection, this line at this intersection, this line at this intersection is cut by a cutting line. So let us not worry about these dimensions, we can have them afterwards again. So this is the lines which are cut. Okay, so this line is separate, this line is separate, this line is separate, this line is separate. So we will be selecting this line, and this line, as well as this line, and we'll make them thin, as these lines are assumed that cut and remove. So that's why we are making them thin lines. And further we can also connect 1 dash to 4 dash. Okay, and we can make it as thick, so which is a visible line from the front view after assuming the section. So once we do this, so we have to project all these points on the true length. So if you want to see the true length of DO here, okay, so this is the true length what we have got, and now we'll be getting the projectors from this 1 on DO, then from 2 to 6, 2 to 6 on DO, 3 to 5 on DO, and 4 is on DO itself. So again we have to name all these points. Okay, so again we can start with, this is 1 dash, this is 2 dash and 6 dash, and this is 3 dash and 5 dash. Okay, so like this you have got all these points here. So now we know the true length of the slant edges, and we know the cutting points there and their distances on the true line. So now we have to do the development of pyramid using method called as a radial line method. So the radial line method or radial line development for hexagonal pyramid will be discussed in the part 2 of this session. Thank you.